Thank you very much for your kind introduction, and welcome, ladies and gentlemen, to my part of our partner webinar, which is about the MyPV components. And also I would like to start with a short introduction with a few words on our company. We are a manufacturer, and the topic that we are dealing with is hot water and space heating from photovoltaics. My name is Reinhard Hofstetter. I'm responsible for international sales at MyPV. I'm employee at MyPV since July 2016. And not only since then, I know POLYSUN very well. I also worked with POLYSUN in my former job. I was a researcher on a Solar Thermal Institute. It was the Austrian Solar Innovation Center. And there I focused on the development, on research and development of solar thermal systems. So conventional solar thermal systems with, as we know it, with collectors, with pipes, with pumps and all that stuff. And I also was a lecturer of solar thermal planning at the University of Applied Sciences in Upper Austria. And what has changed is the application in POLYSUN. While I was using solar thermal applications in earlier days, I'm now using mainly the electric heaters in combination with the photovoltaic component, with the photovoltaic bricks in POLYSUN. I call it bricks because POLYSUN reminds me always of Lego, and I like it very much, personally speaking. And these are the bricks that we are going to use today. There are the two entrepreneurs from MyPV, which is Dr. Gerhard Rimpler and Markus Gundendorfer. And these two guys together have more than a few decades of experience in solar electronics design. They founded the inverter division at Fronius a long time ago. And now they are the masterminds behind our solutions. And for Gerhard Rimpler, it's the same situation as for myself. He also knows the solar thermal side very well. And due to that fact, we are fully aware of all the limits that come with solar thermal systems. All that problems, the topic of stagnation and evaporation in summer, and the maintenance efforts for the anti-freezing liquid and all that stuff, we know it from scratch. And nowadays we are thinking about using PV power for heating instead, because there are two important facts you have to consider. Hot water from PV is many times easier in terms of the technology, and since a few years it's also cheaper than conventional solar thermal systems. And that's why we came up with new solutions for this application, and we were founded in the year 2011. And our first product introduction on the market was in 2014, which was the ELWA. ELWA means electric water heater, and since then the ELWA is our only DC product in the portfolio. In the following years, we invented a few AC solutions, and we are also taking a look on a few of them. While the ELWA can really be compared to a solar thermal systems, the AC solutions are designed to use excessive energy in a grid connected system. So energy that would be fed into the grid is the energy that we are using with the AC solutions. First of all, one more question. Hot water and space heating from PV, why is that? I already mentioned that we are aware of all the limits of solar thermal system, but the key factor which enabled us to invent power to heat solutions is shown on this diagram. We have had an amazing decrease of PV costs. And this decrease is the base for all our inventions. So what we have seen in the same time at solar thermal systems was that there was hardly no price development for those systems. So still there are a lot of materials in the collector systems, a lot of copper, a lot of aluminum is in use, which keeps the technology very expensive. And at the same time, we have had this amazing decrease for PV prices, and this decrease enables us to think about new applications for PV power. And power to heat, hot water from photovoltaics is such an example, and this is our topic at MyPV. What else? It's all about saving energy, storing energy, especially excessive energy that would be fed into the grid. And here we are mainly talking about battery systems. They are all over the media. But for a single family home, a conventional, a typical battery size means a storage capacity of, let's say, 5 kilowatt hours to 10 kilowatt hours. And this is a quite small capacity that has to be bought for much money. As a cheaper alternative, we can use the excessive power for hot water heating. And for example, in a hot water tank of a volume with 300 liters, for example, we have a much higher storage capacity. So we can be a cheap alternative to batteries, but we do not compete with batteries at MyPV. We have a lot of very successful partnerships with battery manufacturers. And for this case, it is very important to know that if there is a battery in the system, the battery should have priority when you charge it. Because once it is heat, once you have done power to heat, and it is heat in the boiler, we cannot get electricity back out of it. That is clear, and that's why priority for the charging should be on the battery if there is a battery. This is a rough overview of our portfolio, and today I would like to show you 3 models in POLYSUN. And I want to start with ELWA. As I mentioned, it is the only DC solution that we have at MyPV. It was our first product. It was invented in 2014. And still up to date, there have not been hardly any changes on the device. The only problem that ELWA had was that this solution was definitely ahead of its time. But nowadays, this kind of application got into the people's minds, into the people's hearts, and it has become one of our flagships at MyPV. And the principle is really the same as for a solar thermal system. We use all the energy from the roof, and we are using it for heat production in the boiler or in the storage tank. This does not matter. There is no inverter in between. All the PV power is used by this immersion heater. To ensure that this works efficiently, this power output, and this is the key know-how at MyPV, this power output of the heater is linearly power controlled. It can adjust its power output from 0 watts to 2000 watts. And above all, there's an MPP tracker integrated in the solution. On the bottom, we cannot see it here in this image, there are multi-contact plugs. So 4 to 8 PV panels can directly be connected to the ELWA. This means a DC input voltage range from 100 to 360 volts, and for a standard PV panel, I'm talking about the 60-cell polycrystalline panel now, we are talking about 4 to 8 panels, but of course this also works with thin film panels, it also works with monocrystalline panels, no problem. The heater has a length of 45 centimeters, and it is connected to the tank or to the boiler with a 1.5 inch connection thread, and this is a very common size. You can find it on most of the tanks on the market. And yeah, the know-how from MyPV is actually in this body here, which is the linear power control and the MPP tracking. You adjust the target temperature that you want with this rotation knob here. And while the ELWA can work also during blackouts, also in off-grid remote areas, it offers the possibility of AC backup. This is an option, and therefore is the mains plug on the device. And it's not necessary to use this mains plug, but if you choose to use it, ELWA will check in the afternoon whether the desired hot water temperature is already reached in the tank or not. And if not, it will draw AC power from the grid with 750 watts. But again, this is an option for European climates. We recommend to use this option only during summertime. We have a lot of solar power available during summer, of course, and we do not need much energy as a backup. For winter time, we would need too much energy from the grid. From my perspective, I do not recommend to use this mains plug during winter time, because this optional AC because the conventional backup energy source is doing the space heating anyway, and usually it also provides the backup energy in the boiler. So it's an option, it's not necessary to use it. And before we are seeing how we created the model in POLYSUN, here are a few more technical details. I already mentioned most of them. One special thing that is possible with ELWA, you can use two heaters in parallel on one and the same panel string, and you can adjust a lower priority for the heater on the bottom. And in doing so, you can ensure, even in very huge storage tanks, to have comfort, to have the required hot water temperature at the top very soon, and the rest of the energy can be used by the ELWA at the bottom. Practically speaking, it is also possible to use them in two separate boilers or tanks, no problem from my side. And enough of the technical details. We are now talking about the ELWA model in POLYSUN. Andreas already mentioned it. There are a lot of different controllers available in POLYSUN, and the one that we are using is my favorite one. It's the programmable controller, because here all the logic, all the control strategies are in our hand. So with just this simple formula here, we can do the modeling of ELWA. And there are two main parts, the yellow highlighted one and the blue highlighted one. And only the yellow highlighted one is required to create a model which uses DC power for heating. I would like to show you this directly in POLYSUN. So there is a standard brick of the PV panel. So this also has an inverter here, but I choose to hide it. Nevertheless, there is an inverter in this model, but this is our own defined inverter, which describes the properties of ELWA, basically the DC input voltage from 100 to 360 volts. So it's not a standard inverter that we are using, because on the real product there is no inverter. So I'm using a 300-liter tank in this model. Of course, this components and the logic of this programmable controller can be used for every other tank that you want. You can also take our formula out of this controller and use it in another model that you are working on, no problem. But now let's see how the formula works. It's really very easy. So the first part means that take all the power which is received from the PV panels and give this power to the immersion heater as long as the target temperature, as long as the temperature in the tank is below 60 degrees centigrade. So this value here actually means the setting of the rotation knob. Yeah, you remember the rotation knob here on ELWA. Depending on the position of this rotation knob, we are setting this value here, and that's it. Yeah, as long as it is not above 60 degrees centigrade, use all the PV power for heating. And this is it. Yeah, no big deal. And I have adjusted 8 panels here, and this is how the system works. In this model there is no other conventional backup heat source, and that's why I also use this optional backup with the mains plug, and I'm doing this with the second part of the formula, which means from 3 p.m. in the afternoon forward, yeah, use 750 watts as long as the temperature in the boiler is below 50 degrees centigrade. Why 50? This is a factory preset from MyPV for the optional AC backup. You can change this with an infrared interface, but I would not go any further on the description of this. The factory preset is 50 degrees centigrade. And the AC backup starts in the afternoon, which actually can also be changed on the real product. Now let's see what POLYSUN tells us about the performance. Please note I have electric consumers in here, but there is no profile in the background. This is just to get the results also for the electric consumers. So let's start the simulation for the first time, and POLYSUN is calculating. Very nice. And the two most important things to me can be found at electric consumers. This is the degree of self-sufficiency, and usually this this part describes how much energy for your building, electric energy for your building, can be provided by the PV system. This works for all the AC models, but actually for the ELWA model this means a different thing. This means the so-called solar coverage ratio, which means how much of my energy demand for hot water heating can be provided by the sun. The definition, the word is another one, but the definition and the value are still valid. So 54% of the annual energy demand for hot water heating can be provided by 8 panels, and the hot water demand that has been defined is the demand of 4 persons. So we are talking about a single family home here, and more than the half of the energy can be provided by 8 PV panels. And what else? The self-consumption fraction, which means how much energy can be used from the PV system directly in the building. So technically speaking, there is no way to feed into the power grid, but the POLYSUN model does not know. And what we are seeing here, so the rest of 11.5% is the energy from the PV panels that cannot be used for anything. Why is that? Because during summertime we are on target temperature in the hot water boiler, and then the ELWA has to shut down, and then the PV power is not used for anything. But this is without all those disadvantages that we see during summertime on solar thermal systems. But because of course there is no stagnation, there is no evaporation in a PV panel. It does not harm a PV panel at all when you do when you create a short circuit on the. What is the English word for short circuit? I'm sorry, I missed it, but you know what I mean. You can connect plus to minus directly, and this does not harm the panel. So a lot of advantages, and we are asked quite often, what happens to this rest of the energy? I cannot use it. Actually, you do not have to use it. This very little part that cannot be used for anything is so small, it would not be worth to spend money on an inverter for that. Yeah, so this is not the big deal here. So just less than 300 kilowatt hours a year cannot be used. And in doing so, with this principle, we think that we create power or heat from sun many times easier. You see on the left side how a solar thermal system works. We have huge thick collector systems. We have pipes. These pipes have to be welded. They have to be insulated. You need a pump. You need an expansion vessel. You need a control with wires for the temperature sensors. And you need a backup heat source in every case, because once there is no heat from the sun available, you would not have hot water available. And now let's take a look on the ELWA principle on the other side. While I was working as a researcher for solar thermal systems, we always looked for a plug-and-play system, but we never ever made it to the market. And today we have a solar system, a solar heat system that is so easy to install. My 5-year-old son would be able to connect these plugs together. And of course there's always this option of AC backup, so you do not even need the conventional heat source for this. So wires instead of pipes is one of our slogans, and PV power has become so cheap. We can also make it many times easier. Not only many times easier technically speaking, nowadays we are also making the system cheaper, and that's the key fact. It's so cheap we can think about using PV power even for heating. And I would say this is quite a good time for our first break, Andreas, because this is the only DC product that I'm going to introduce today, the only DC solution we have. And before we start looking at the AC solution, maybe we should take a look on the questions, if there are already some questions.
Yes. One question is regarding the maximum DC power input which would be suitable for ELWA.
What really matters is the DC input voltage. It has to be within a range of 100 to 360 volts. And it's no problem when you overpower ELWA with more than 2 kilowatt peak. You can also use more panels or more powerful panels, let's say a 330 watt peak panel, and you're using 8 of them serial. This is no problem as long as you are below this maximum input voltage. Why is that not a problem? Because ELWA is able to limit the current by itself. The current is always limited to 10 amps. The only danger for the product is a too high input voltage. What we are recommending from our experience is a 2 kilowatt peak system for a single family home. But we also have done a lot of apartment building projects here in Austria, where this DC system is separated for each apartment. So each apartment has its small hot water boiler with a size of, let's say, 120 liters or a little bigger. And there we recommend to use 1.5 kilowatt peak only for the ELWA. 2 kilowatt peak is a quite good size for a 4-person household, for a 3-person household, for a 2-person household, or a single family household, a single person household. We can also use less panels, of course. This is possible.
Okay, good. And another question is regarding the temperature range which is permitted for the water in the tank.
So the maximum target temperature that can be set on the knob is 75 degrees centigrade. And this has to be considered very well depending on the calcium in the water. For Austrian conditions, we have a lot of calcium in our water here. I would say probably it's the same in Switzerland. We recommend to set a maximum target temperature of 60 degrees centigrade, not more. Of course, in storage tanks, in heating water, we would not have a problem with calcium. You can go up with the target temperature to maximum, no problem. But for drinking water, this has to be considered, please.
Okay. Then we have a number of other questions which are especially regarding the comparison with solar thermal in terms of efficiency and also in terms of costs. But of course, now the time is limited. Already we have a 36-minute fast. We have not even looked at the second and the third part of your presentation. So therefore, ladies and gentlemen, who has asked these questions, I would like to ask you to be patient. We will answer these more complex questions later on by email.
Okay, maybe just a short answer on the topic of efficiency. I worked on a test stand of flat plate collector systems, and the people always came to me and asked. They were so skeptic about hot water from PV, and they ask, but a solar thermal collector, it has an efficiency of 80%. How can you deal with a PV now? And it is always very difficult to describe to them that a solar thermal system never ever has 80% efficiency. What 80% of efficiency means is a test situation for the collector. And during this test situation, there is no heat output. So this is so, it's not relevant for a practical system. Of course, a solar thermal system have a system efficiency in real operation of, let's say, 40%, 50%. And of course, with a PV panel, this is less. No question at this point. But what the big deal is, the big advantage of PV hot water systems is that we have this long operation time. The very first sun ray in the morning is already transferred to the boiler without any losses. You do not have thermal losses in between. And we have this long operation times. We have ELWAs out there with 16 hours, 17 hours of operation during the day, and also at lower power output with longer operation time. We have the energy at the end of the day available. And even on cold days, the PV system works more efficiently, while a solar thermal system efficiency decreases. And one of my favorites is that also on cloudy days with low or without any direct sun radiation, this system operates and provides hot water, while a solar thermal system on the same day would not do anything. So this is one of the greatest technical features when we compare those systems.
Okay. Well, regarding the payback time and all this, maybe we will really reply by email, because obviously we need to do a comparison. Or maybe you want to say something about that as well. But in any case, I would say that we could do later. One very simple question, which is going into the commercial direction, is the product available in North America?
Not yet, unfortunately. We can send it to North America, but we do not have the certifications for North America so far. And but it's not due to the fact that North America has a 60 Hertz power grid. The ELWA would be able to work even in 60 Hertz power grids, or the AC backup would be able to do so. This is a question of permission and certification, but we have not done the step to North America so far.
Okay.
Unfortunately, I'm sorry.
Okay. So thank you for these explanations. I would suggest that then we proceed with the AC systems.
Very well. So we are talking about on-grid systems now. So these systems have usually more than just 8 panels. I'm talking about 5 kilowatt peaks, 8, 10, or 20 kilowatt peak system, whatever, does not matter. And of course there is an inverter. And the power from the AC power from the inverter usually provides the electric appliances in the building with priority. So the light, the devices, and so on. And the rest of the energy usually is sent back to the power grid. Let's assume that there is no battery at this stage. So the rest of the energy is sent to the power grid. For a single family house in Austria, we are talking about usually 5 kilowatt peak system, maybe more for the future. And therefore this means a self-consumption ratio of the PV power of only 30%. 70% on average are fed into the power grid. So we want to use this energy and we want to avoid feed-in. And the question is how much PV power is available before we fed it into the grid. And this power has to be measured. One way to measure this is the MyPV power meter. And this power meter sends the information to the AC ELWA-E via Ethernet. So usually there is a router in between, but these components can also be connected directly together. And while ELWA was capable of linear power control from 0 to 2000 watts, the AC ELWA-E is able to scale up its power output to 3000 watts, 3 kilowatts. And the letter E at the end means Ethernet. So there's an RG45 socket at the bottom, and via Ethernet the AC ELWA-E receives the excess power information from its signal source. It does not have to be the power meter, but more on that later. The energy that is used by the heater is always drawn from a main socket. Sorry. But it only takes as much power out of this socket as is available, which means if you just switch on the light in your living room here, you have less excessive power available, and AC ELWA-E will immediately reduce its power output accordingly. We avoid feed-in and import from the power grid, and for the combination with our own power meter, this balance in the feed-in point is done very fast and very accurate. 1 time per second. This is done for every watt. So each watt between 0 and 3000 watts is possible. For the socket, we recommend to use a separate fuse because in case of 3 kilowatt power output, also a fuse can be blown once there are other consumers on this circuit. So use a separate fuse in that case. The dimensions of the heater are exactly the same as for the DC solution. So this cover here is quite small. I have not mentioned that before. It's approximately 13 times 15 centimeters, and the heating elements are 45 centimeters long, 1.5 inch standard connection thread. And for the excess power detection, there's the power meter from MyPV as an accessory part. And here we also have the technical data on AC ELWA-E. I'm skipping the content of this slide now because we have to focus on the time progress. You will receive the slides of today's webinar anyway, maybe tomorrow from my side. As soon as I have your contact data, I will provide it immediately. So let's go to the model in POLYSUN directly. Again, we have the yellow highlighted part, which means the PV power, and the blue highlighted part, which means the optional AC backup. And again, if you do not want to use this optional AC backup, you just remove the blue part of the formula, and that's it. Nothing else. And here we are on the POLYSUN model now. For the yellow part, for the PV part, the formula is nearly the same. There's just one value more. We use the energy from the PV, yes, that's correct, but before we are using the energy for the immersion heater, we subtract the current energy demand of the building. So only the excessive part remains, and we are doing this as long as there is a temperature below 60 degrees centigrade. And again, this is the value of the rotation knob, and of course you can adjust this. The optional AC backup means now full power. So instead of the 750 watts, we have now the 3000 watts in the formula. But this is also only activated during time frames and on the web interface of the heater. You know, it is connected to the router, and of course you have Ethernet access to the heater. And on this web interface you can adjust 2 time frames for AC backup. And again, if you do not want to use the AC backup, just remove this part of the formula. And this is, by the way, the factory preset. So when you take out AC ELWA-E of the box, it only uses excessive energy and not the backup part. I'm leaving I'm keeping this backup part now in the formula to show what happens. The brick of the PV is now a little bigger. I have adjusted a 5 kilowatt peak system in this model, and of course there is now also a profile of the electric appliances. This is a difference to the ELWA system. There was no consumption of the electric appliances. Now we are on the grid. We have to use power from the PV for the electric appliances with priority, and just want to take the energy that would be fed into the grid. So let's take a look on the results. And I like this detailed view of the component results so much, because POLYSUN allows to copy all those results, and you can use it for Microsoft Excel or whatever. This is really a great thing here. And while we are talking about the self-consumption fraction of approximately 30% in a normal single family home, so without a battery, without the MyPV solution, we are talking about a self-consumption fraction of 80% now. And again, this is times less investment than the investment for a battery. And this can be a cheap alternative to battery systems, of course, but we do not compete with batteries, and that's why we are talking about compatibility now. I already mentioned there is a huge number of inverter manufacturers, of battery manufacturers and smart home systems who are already able to control the AC ELWA-E. And if you have one of those signal sources available, it's not necessary to use the MyPV power meter. It's not necessary to use our accessory part then, because the excess power information is provided by one of those. And let's keep a few more minutes on the topic of self-consumption. There is this diagram from the Technical University in Berlin. And for a single family home, this diagram shows a self-consumption ratio of 30% in a single family home, while we are talking about a self-consumption ratio of 2/3 of 66% when we are installing a battery. And power to heat with a MyPV solution can raise the self-consumption ratio even higher to 80%, for example. And if you combine both technologies together, we have a solar car average, a self-consumption ratio of more than 90% in this example. And this is what we are talking about now. If there is a battery, battery should have priority, because once it is heat in the hot water boiler, you cannot get electricity back out of it. That's clear. So power to heat is always the last application before you fed into the power grid. Then the formula has become a green part, and this green part also considers the state of charge of the battery, which means that only if the state of charge of the battery is higher than 98%, I'm sorry, then 98%, then we would use excessive power for heating, and we will not start earlier. And one very important thing, if you use this blue part, this optional AC backup, you will lose all the advantages of the battery. Why is that? Because in the evening, when there was not enough PV power available to do the hot water heating, and the optional boost backup starts, AC ELWA-E will take the energy from the battery, which means you're just moving energy from the green area to the red area, which immediately destroys all the battery advantages. So my personal recommendation, if you have a battery, then you have usually another heat source as a backup, because of course you can use the optional AC backup also from the MyPV side, but you have to be aware that you are just shifting energy from A to B. And this means losses for the charge of the battery. This means losses when you discharge the battery, and this means high investment cost for the battery. But for what? Just to create heat in the end. There it is better to create heat immediately without any battery, to be honest. Nevertheless, it's up to you, up to the planners, how you use those systems. You have this components available. You have the models available at POLYSUN. And here we have now also the part of the battery, and the state of charge of the battery is considered here. For my hydraulic model, there is no thermal backup source. So that's why I'm still using this formula part of the excess of the optional boost backup. Otherwise we would have an error message that there is not enough hot water. But I want to show you what is possible when we combine both technologies together. And here we see a maximum self-consumption ratio, where it is, electric consumers, of nearly 90% in this example. So from my point of view, power to heat is a key part for the transition of renewable energies, even when there is a battery in the system. Because let's imagine in a few years when I'm looking out of my window and I see my neighborhood, all of the buildings, or hopefully most of them, will have a PV system on the roof, and most of those PV systems will be equipped with a battery as well. But what happens at 11 a.m. when all the batteries are fully charged? I would like to tell you the grid operator will shut down the PV systems. That's a fact, because he has to do so. Yeah, he has to save its power grid. The power grid is not able to transport all of this excess energy from all those PV systems. So the PV system has to shut down, and this is. I can understand this from a technical perspective, but it is an absolute disaster for the transition to renewable energies. But because what happens in the evening when we need hot water for showering? Are we starting our gas boiler then, or what are we going to do? Or will we be clever enough to use this excess power for power to heat applications? This is some deeper thoughts at this stage, at this point, which are very important to me. And we have now finished all the three models. There are two products from my PV that I'm going to show you just for a short minute, because the advantages of AC ELWA-E, or one of the advantages of AC ELWA-E, is that the immersion heater and the power stage for the linear power control are combined in one product. But what if you already have an immersion heater, a standard electric immersion heater, which is able to shut on and shut off, but it's not able to do linear power control? What are you doing then? Then we can use another product, and this is the Actor. So the Actor is not a smart home system, because with this color touch display, much people are reminded of a smart home system, but it's not. It's an AC power controller, and with this AC power controller you can make a standard electric heater PV ready. You make it PV ready in terms of linear power control. So imagine the green AC ELWA-E, but instead of the immersion heater we have a main socket on the device, and this is available in a single phase variant, also for a power control of 3 kilowatts maximum, 0 to 3 kilowatts maximum. But it is also available for a 3-phase variant with a maximum power output of 9 kilowatts. So it's very compact. A 9 kilowatt power controller that is so small is really very unique on the market. And by the way, there are a lot of unique sales points for this product. One of them is the size. Another one is the color touch display. Then the third one is the communication. We are open for third-party control, and I give the communication protocol of this interface to everyone who wants to work with the device. Of course, the excess power information can also be detected by the MyPV power meter. So we have the same compatibility options as for the AC ELWA-E, and here are most of them. So inverter manufacturers, battery manufacturers, and smart home systems can control also the actor in the single phase and in the three-phase variant. What else is great on the Actor 9S, as we call the 9 kilowatt version? All three outputs are controllable. So not at the same time, but we can do the linear power control either here on output 1 or on output 2 or on output 3, and altogether the maximum power output is 9,000 watts. What else? The kind of power control that we are using in all our products is the same power control as it is used by PV inverters. We do not use thyristors. We do not have the so-called phase angle control, which is very important for the grid operators, not only in Switzerland but also in Austria and Germany. This topic becomes more and more important, and with a MyPV product you can rely on a high quality solution. So it works as a PV inverter. Where to buy? On our website you can find the information of our distributors, of our wholesalers worldwide. As a manufacturer, we are not selling to private persons, we are not dealing with the end customer, but we have a very well developed distribution network in many countries. Detailed information are of course available anytime in the download section on our website. Not only the manuals, not only the wiring diagrams, but also the records of webinars that we have done. And a few of them are also available in English. So my recommendation, if you want to go into more detail here, just inform on the MyPV website. And of course, another way to get information is YouTube. So far, unfortunately, most of the videos here are only online in German, but YouTube offers a quite well subtitle translation, which can be activated easily for each video. So please also take a look on that. And looking on my clock now, we are just on time. Andreas, are there still questions?
Yes, well, there are more questions, and one question I will answer directly. One person has asked if the MyPV systems are now available in POLYSUN, are available to all POLYSUN users. Yes, that's the case. You have them, Reinhard is showing it to you now. Among the company templates, you have a folder called MyPV, and you have all the templates in there, so you will be able to simulate by yourself what Reinhard has shown to you today, and also then of course do also the profitability calculation, because that is a question which was asked several times. But of course it depends also upon the system, upon the situation, upon the consumption. But of course, you, as you know, in POLYSUN you have got the possibility to compare also solar thermal systems with PV systems, and so you can define both of your systems and then go into the menu results, define the economic conditions for both systems, and then go to the comparison of the profitability calculation.
Okay. Yeah,
so,
yes, Andreas, you also promised
to do
to.
it by yourself too.
Sorry, I do not want to interrupt you.
No, please.
We already talked about creating the alphabetical order for MyPV, because I'm afraid it's hard to find our models here at the bottom, and I'm looking forward to it.
I absolutely agree. And probably this is because of the small letter M, because you see E side is also starting.
No.
Well, of course, it's also the Z, but it's in the end of the list.
No problem.
Anyway, for everybody who is following this webinar, you can find my TV at the bottom of the list, last but not least. I really want to underline it, last but not least.
No problem, Andreas. Thank you very much. Maybe a few words from my side on the profitability comparison. What I'm going to show you now is a small online tool. So this is really just an online tool. It's light years away from the dynamic annual simulation program of POLYSUN. So this is just to inform yourself roughly, and you can also choose a location, and you can set electricity rates and energy demand here for a very rough, quick overview. Andreas, this is light years away from the tool that you have created. I hope you are not afraid that I'm trying to compete with you at this point. Definitely not.
Yeah, and so one person was asking if you can quickly show an example of such a comparison, probably the profitability calculation. You have to prepare first both systems among your system diagrams. Maybe, Reinhard, you can quickly show in POLYSUN the results menu.
Okay.
Yeah, and there you have got you can just stay there, and there you see you have got profitability calculation, which you do first. So first you define all your conditions, your prices, your investment costs for each system in profitability calculation. This will be highlighted once you select a system diagram, and when you have when you have set your values for both systems, which you want to compare with each other, or for all 3 or 4 systems, then you have to set one system as a reference system, which you do by clicking on the system diagram with the right mouse button, and then you highlight it as reference system. And when you have finished that, then you go on to profitability system comparison, and you will see the results. So this is just a general answer, because now we really don't have the time to show this in detail, but please send me an email. You can also send me your project if you have questions regarding a system comparison. Just send it to me. You have got my email, and then we will follow you individually.
Okay. Perfect.
So I think for the moment that's it. I confirm that everybody will receive a link at the end of the webinar from which you can download the record of the video of this webinar, so you can watch it again, and as I said, all the other questions will be answered by email later on.
Okay.
So, Reinhard, if you don't have any more issues, I would thank you very much for your, not for your attention, but of course for your presentation.
You're welcome.
I thank you, all of you participants, for your attention, for your active participation, and of course we will be in touch through the usual channels.
Perfect. Andreas, also from my PV and in the name of my colleagues, I want to say thank you to Velasolaris and to your POLYSUN team. It is really a very important tool for us. We do not only recommend it to the planners, we're also using it for our own development, because it's really great. You combine all those important parts of the energy in one product. So the combination of the electric part, of the heat part, this is essential for our solutions, and that's why we have found the perfect tool with POLYSUN for us. Thank you very much.
Thank you, Reinhard. Thank you very much. So thank you all, and have a nice evening or a nice day wherever you are.
Thank you very much.
Bye-bye.
Goodbye.